From what I understand, about half the material that we talked about today is stuff that you've already known. 45% of the material that we've done today is stuff that we can adapt from what we've already done. And 5% of it's just made up anyway, so it doesn't matter. So, angles. Angles are just two rays with the same endpoint. That's all they are. Angles are made up of two rays with the same exact endpoint. So when you have a ray, Waffle House.
You have one marker.
I want two.
Wait, what? Yeah, the other one. I like how he's already recording and then no song. He records and he puts it away. Yeah. Oh, yeah?
Hi, everybody. Anyway, so angles are two different rays with the same endpoint. So when we label these things out, I made a note here to remind, or wanted to make sure I spend a little extra time to talk about how the labeling works. If you have a ray, when you label it, you always start with which letter? Why do I start with B in this case? It's the endpoint. Whenever we talk about rays, we always label the first letter is always going to be where it has the endpoint. So this case here would be ray BA and ray BC. So what we know is ray BA and ray BC create what's called angle ABC. And I use a little bit different angle symbol than what the book does. I take basically the left hand symbol, and I put a little arc in it. That's all. It's a little different than what other people do. It's more of an old school way of doing it. It was the way that they taught me when I was in high school geometry, just to put the lessons that they put an arc. Because when you start to go through angles later on in triangles and things like that, when we start talking about what's called congruencies, this angle is congruent to this angle. So it's just a way of marking. It's something like that. So that just stands for angle. And I would call this angle ABC. This middle letter is called the vertex. The common endpoint of an angle is the point that's shared on both rays, and it's called the vertex. And it's always, always, always the second letter when you write it out with three letters. Angle ABC has a vertex at B. Angle XYZ has a vertex at Y. Angle 1, 2, 3 has a vertex at 2, and so on. I'd say about 90% of the time, you're always going to be writing your angles out with three letters. It does not matter what direction you go, as long as your vertex is the one in the middle. So angle ABC is the same as CBA. It means the same thing. As long as B is in the middle, you're fine. Okay. What's up? Isn't that doubly redundant? Another way sometimes you'll see it written is sometimes you'll see it written as just plain old boring angle B. And we shortcut that if and only if there's only one vertex of B. Yes, ma'am?
What's the definition for sides?
Oh, sorry, I didn't mean to throw that label over there. The sides of an angle are just the rays that make it up. That's all. So the sides of this angle are ray BA and BC. That's it. It's not something you see very often, but I figured I'd just throw it in there for us. What I was saying here is that you can use one letter for an angle only when it's only one angle that can be used with that letter. What I mean is sometimes you'll have Wow, that's not even close to the intersection in the middle. Sometimes I'll have an intersection point in there with 6 different rays, and this could still be point B. So this could be A, C, D, E, F, and G. I can't call this angle B right here because B is a shared vertex for, let's see, 1, 2, 3, 4, 5, 6, 7, 8. See how many different angles you can get out of that? You only do it when it's only one possible angle. So always, if you want to err on the side of caution, just use 3 letters. Okay. I'm pretty sure you guys have all seen that before, right? So the other part of these things then is how we actually classify it. And what I mean by that is there are 4 ways to classify angles by their measure. Move this over a bit. First thing I want to say is, how are angles measured? Yes, ma'am.
I was going to ask, what does it look like when it only has one possible?
But just like the one I just showed you. If I do this, if I make a triangle and I call it X, Y, Z, is there only one angle that has X as a vertex? That's why I can say this is just angle X. All right? I could still call it angle YXZ. It means the same thing, but sometimes it's a little bit shorter to write it as one. But if it had another line going through it like this, to, let's say this is an R, I can't call this angle here angle X, because it could be this one, or the whole thing. Does that make sense? Good question. Say goodbye. See you later. Sign up. Remember how you measure angles? In inches, feet, miles, degrees. Measurement degrees. For our purposes, I'd say pretty much every problem we deal with is going to be between 0 and 180 degrees. Next year, you'll worry about going past 180. So if you want to look at it in terms of ways to classify the angles by their angle measurement, their degree values, what's one type of an angle? Acute angle. What makes an acute angle acute? It's small, it's little. It's cute, it's little. An acute angle. What does an acute angle measure between? Remember? It's an angle who measures less than 90 degrees. Oh, whenever you see M in front of an angle symbol, it just stands for measure of the angle. Are we okay with that? But it has to be great if it's less than 90, but it has to be greater than what? 0. So the measure of an angle that's acute is always going to be between 0 and 90. Because what happens when it becomes 90 degrees? It's what? It's right angle, good. A right angle, a lot of times people write it like this, RT angle, because writing the word right is too long, too many letters. It's true, that's why we use symbols. Math is fun that way. A right angle is an angle who measures how much? It's 90 degrees. Do you know how they show a right angle in a diagram? What symbol do they use? Really? You've never seen it? I'll be surprised. What if I showed you this? Do you ever see the little square in the corner?
Oh, yeah.
That's what that means. The reason they use a little square is because of, honestly, because of carpentry, when you're building stuff. If something is square, you know it forms a right angle. One of the other things that people use with right angles, which does happen all the time, let me ask you this, have any of you guys ever helped frame a wall, 2x4s, and you measure it out to build up a wall in a basement or something like that? When you did that, did you measure like 3 feet out one way, 4 feet out another way, to see if it's square? What you're doing is, by doing that, you measure 3 feet one way, 4 feet the other way. If this is going to be a right angle, this Pythagorean theorem would have to hold true, which means from here to here would have to equal 5, because 3 squared plus 4 squared is 25. Square root is 5. They do that all the time whenever you're building anything. If you're putting up cabinets, doing countertops, building walls, framing out to pour concrete, doing a paver base or something like that in a patio, helping build a deck. It's one of the easy ways to make sure that your framing that you're building is square. That's what we call it. That's why they use a little square thing. So right angle measures 90. What's next? Obtuse. Obtuse measures what? But less than? Less than what? Good. So it's greater than 90. Oops. But less than 180. What's the last one? You ever heard of straight angle?
It's
Yeah. It's just an angle measured 180 degrees. Basically, when you have 3 collinear points, what do they create? A straight angle. Oh, yeah, that's what that is.
What?
Oh, you should have, because it would make you feel better.
No. You are so rude.
One quick thing. Am I going to be really, really distraught, upset, weeping, crying, cowering in the corner if you forget to put the degree symbol?
It's gonna be me.
No, really.
You
I'm
know,
going to.
suggestions most people would be sitting there sobbing.
I forget half the time myself. It's really not the end of the world if you forget the degree symbol. Hey, I'm happy you remember the math. If you forget the degree symbol, it's not that big of a deal. What's that?
You got it wrong last year.
It's okay. Really, the only thing the one thing that I have to make sure that you guys really pay close attention to is when we start talking about units, like for surface areas and volumes and length and stuff. That's when I really worry about labeling correctly. If you forget a degree symbol, is it really the end of the world? In mine, you're gonna be okay. All right? Not too terrible so far? Again, I know all of you guys have seen that before, right? Yes, Mr. Murphy, we all went to elementary school and middle school. Nice thing. Oh. Which gets you to good old-fashioned angle addition. What do you think angle addition is going to look like? What did we just get done using? Segment addition. I bet you guys remember that segment addition was 2 smaller segments add together to equal the larger segment, especially when they're collinear, they had to be. So what do you think angle addition is going to do? The exact same thing. I know. It's the exact same thing, all right? Angle addition and segment addition are identical. One has an angle, one has a segment. That's it. Angle addition. 2 smaller angles with the same vertex can add to equal a larger. It's basically all it is. Just like when we had segment addition. If you had points that were collinear, x, y, and z, we were able to say xy plus yz equals xz. Angle addition is the same thing with more letters. That's it. It's the same thing. Since they all share that common vertex, that's the only thing you got to be careful of. Yes, sir.
But what if there's two vertices?
What do you mean?
Like on the
Here, draw it.
Wait.
I'll go back. Don't worry.
No, I had like one more word.
It
was the larger one.
But don't these two angles here and here, don't they share that same vertex?
Yeah, but if there was like,
He doesn't. Do you really? Oh, I have that.
yeah. That's
See, what you're thinking of, and this is a good question, what you're thinking of
I'm
is
gonna draw like a
another angle over here.
Yeah.
These two angles, guys, this is a great question. What he's asking is, what happens if you have another angle that's not part of this bunch? Could I still add it to it? These are what you call non-adjacent. They're not next to. They're not sharing a common side here, okay, a common vertex. We're not going to be adding together adjacent, non-adjacent angles. I'm not worried about that kind of stuff, all right? So you're looking at like doomsday scenario. Don't worry about it, okay? So going back to this one, when I label this out, for example, if I start to write out the lettering of what it's going to look like, this is where you just got to be careful about not messing up with your letters. So we start with angle ABD. And for those of you guys that have crummy handwriting, you really want to be careful with this. Angle ABD plus angle BC equals angle ABC. Notice what all three of those angles have in common. B. Notice it's the second letter for all three of them. Which means it's the what for all three of them? Vertex, very good. All three of those angles have the exact same vertex, so I can add these guys together. So I could say, hey, if this is 33 and this whole thing is 98, how much is that? Hey, buddy! What do you do?
Stop playing video games on your phone. You're not drinking and hiding it.
You want to learn how to be good on your phone and hide it? Watch a girl. No, it's true. You guys are better at hiding it than he is. Yours is just, I mean, you're not even trying to write anything down.
Actually, you're
Oh. So, what do you do to figure out the missing angle? That's it. That's it. Isn't it the same thing as you did here? If this whole thing was 12 and this much was 4, what would you do?
Just try.
It's the same thing, ladies and gentlemen.
Oh, it is?
It's nice. Yes.
Oh.
So 33 plus something, you can use a variable if you want, is 98. What's x?
65.
X is 65. Very good. That's all it is, guys. Angle addition. Angle addition is the exact same thing as you would do segment addition. It just has more letters. That's all. Do they still make alphabet soup or alphabet cereal? You ever seen that? Alphabet cereal?
No.
Alphabet cereal was kind of like Cheerios, but they were the alphabet instead of little Circles all the time. You know what I saw the other day? I actually bought it over the summer. Fruit Loops with Lucky Charm marshmallows. I'm lucky I'm not like 400 pounds after I saw that. What's that? Did you see that? I saw that at Aldi once, and we bought a box when we went to go camping. I think my children and myself ate it in like one sitting. And we said, yo, we can't eat this anymore. If you see it, it is phenomenal. It's so good.
I was creamer. She had like a year and a half left. Everything but the marshmallow. It was not even full of marshmallows.
All right, if I go back to stuff like this then.
It'd be like a new
It was so good. It was so good.
tries out and really live.
Oh, Fruit Loops with Lucky Charm marshmallows. Oh, it's delicious. So good. So in this case here, do we have two angles that share a common vertex?
Yes.
Yeah. Angle EFH and angle HFG, they all share a common vertex. It's at point F, which means I can add those two together to add up to equal the whole. So 37 plus 19 equals
56. You say
That's
it's
it.
probably 50.
Math is easy today. Math is easy.
Oh, that makes sense.
Yay.
Okay, I'm throwing it back. So like, how do you find the x variable?
Variable for this one?
No, for like this line segment things from like last week.
For this?
Yeah.
All you gotta do is this. I'm trying to figure out what this is. Small chunk plus small chunk equals the whole chunk.
Well, like okay.
4 plus x is 12.
It was on the test yesterday.
Oh, I'll go over that when everybody's done with it. Okay. Let's show you another one. Sometimes they'll throw the geometry at you.
That's the.
I will show you.
Bet.
Not only are you working with just numbers, angle addition and whatnot, sometimes you have a little bit of algebra to worry about. So in this example, we have angle NRQ. NRQ is made up of two other angles, angle NRP and angle PRQ. It tells you that the whole thing measures 78 degrees. And then it's asking you just to find one part of the angle. So you will have to solve for x and then substitute back in at some point. So just like you were asking, this is exactly the same thing as if the segments were, if this much was 8x plus 7, and this is 4x minus 1, and the whole thing is 78, it's the exact same problem. The only difference is now the angle itself here is the 78, and this part of it was the 8x plus 7, and this part was the 4x minus 1. All we're doing is, instead of going straight across from one another, we're turning. That's it. It's the only change here, guys. The math, the algebra is the same. So what we do is we write it out. You can do one of two things. So you can start with the whole angle addition. Angle NRP plus angle PRQ equals the whole thing, NRQ. Personally, I probably won't do that very often because there's a lot of letters, a lot of symbols, but I can just recognize that I've got two chunks to equal the whole and just do that right off the bat. 8x plus 7. 4x minus 1 equals 78. And now you're at a two-step algebra problem. Combine your like terms. What's 8x and 4x? 12x. 7 minus 1 is?
All right.
Oh, you're finishing it. Okay, I was like, wait, huh? That's all right. And now what do? Subtract the 6, and you get 12x is 72. You get 6. The question asks you to find PRQ. Whoa. So we substitute back in here. So we have 4 times 6 minus 1, and you get? Very good. Am I going to yell at you if you don't put degree symbol there?
No.
Okay. Like I said, guys, there's not a lot of craziness involved in this. It is a lot of the review of the exact same stuff we've done the past few days, just with angles now. Which means after we did angle addition and segment addition and all that, remember when we talked about segment bisectors? What did a segment bisector do?
Bisect the segment.
It bisects a segment, which means it cut it into what? Two equal parts. So what do you think an angle bisector is going to do? It splits it into 2 equal parts. So an angle bisector splits an angle into 2 congruent angles. Before we talked about segment bisectors, we talked about segment bisectors being possibly points, lines, rays, segments, whatever. In this case, when we talk about an angle bisector, I'd say 9 times out of 10, or even 9.5 times out of 10, you wind up with a ray going through the vertex. And that's how this one winds up working itself out. Again, it is a very, very simple thing to work with. So if I have an angle, let's say we have angle X, Y, Z, and angle XYZ is 122 degrees to start with. And Y, we'll call this YR. YR bisects it. What do these 2 angles become then, if the whole thing was 122? There you go. All you do is cut it in half. That's it. If the whole thing was 122, it means each chunk then has to be 61. That's all. When you did this with the algebra, with segments, if you had algebra-wise, you had to solve for x and figure out the lengths. You just set those 2 terms equal to each other. What do you think's going to change with the angles? Nothing. Absolutely nothing. Okay? So let me show you an example of that, and then I think we'll be well on our way. Can I go?
No.
Today, Junior. What was that, Billy Madison? Yeah. Thank you. So what'll happen then is you'll get something like this. It'll say that ray BD bisects angle ABC. Find the measure of angle DBC. So when I start the problem out, just in reading what's going on, we look at it and we see that we have angles ABD and angle DBC. Those are what have been bisected from angle ABC. But look at what they wrote. They actually wrote 11x minus 12!
Jesus.
Because they have an exclamation point, because they're really, really excited. That's not what it means. It just means there was a typo on some of the worksheets. It should be degree symbol. It somehow yelled it with an exclamation point.
Me. Oh gosh. Did you know?
You see, this book is notorious, guys. They're not yelling at you. They're not yelling at you with the exclamation point. They're not asking you to take a factorial. They just, for some reason, it just printed out as an exclamation instead of a degree symbol. So don't freak if you see an exclamation point. Nobody's mad at you yet. Okay?
She said
So,
she did too.
algebraically then, what do I know about those two angles?
They have to equal a total,
No. What do they have to equal?
the same thing.
Each other. They have to equal the same thing because it's been bisected. That means that these two angles are the same. 11x minus 12 is 8x plus 3. Exactly. And you pick on the little guy.
So like, it always refers back to like an algebraic
Yep.
expression.
Yep.
Or function. That makes sense.
So in this case here, who do you pick on? The 11x or the 8?
8.
Yep. Subtract the 8x to the other side.
Yep.
At the exact same time, we're going to add 12. I get 3x is 15. Therefore, x is then
5.
5. So if x is 5, I wanted to figure out what dbc is. What do I do?
Plug it in.
Yep. Substitute back up here. What's 8 times 5? 40 plus 3 is? And does it take long to double check to make sure it's correct on the other side as well?
No.
What's 5 times 11?
55.
55. 55 minus 12 is?
I'm thinking it's wrong.
So we worked out okay. All right? Really isn't that difficult, is it?
As if you go slow with it, it actually makes a lot more sense.
And that's the idea here. It doesn't change from the segment stuff to the angles. They're you're using the same properties, really. It's just they're turned as opposed to being straight. That's it. It all works out the same. Okay?
Someone just bends the line.
Sure. Last little quick description here. I know we're going to spend a little bit more time on stuff like this tomorrow, but just for example, real fast, I don't want to get too crazy on this one. Just thinking about it, what would those two angles have to add up to equal?
180.
Good. What's A? 20. What would these two angles have to add up to equal then?
Also 180.
What would
so
B?
I'm not. B would be 1. So they're both like each other.
I have already put the homework on the calendar. I will put it on here as well. It's just the very next page in the book. The next section, I can say, it's 1-4. It's on page 29 in the book. 22, 27, 29 through 31, 33 through 42. Okay. And honestly, it probably won't take you more than 15 minutes. If it takes you more than 15 minutes, you're really goofing up somewhere along those lines. But you have a good, 8 minutes or so? Yeah, about 8 minutes or so to go ahead and get started on that. I'll pull it up here in a second and see if you guys can get at least the first few of them done. Okay? Yes, ma'am. That's fine.